I'd like to welcome everybody to calculus today. Good to see you. First order of business, we'll go over the test. Some really good things and some really bad things, that's all. Overall, both classes combined, actually all three classes combined, you and fourth and grade C, your multiple guess skills have gotten so good. And I don't know whether it was just because it was this test or you actually knew what you were doing. Free response, not too pleased with, but multiple guess was really, really good. All right, multiple guess, non-calculator, number one. The area under the curve of f of x equals x on the interval from 0 to 2.
Please.
You know, I put this one on here to see which of you were mindless robots and which of you were actual thinkers. How many of you took an integral on this one? Antiderivative of x from 0 to 2, is that cool? Is that what we did? All right, let's try it that way first, because that's how a lot of people tackled this one. All right, straight up antiderivative, so 1/2 x squared from 0 to 2.
Put a 0 in there.
If you, well, stick 2 in there, stick 0 in there, and subtract in that order, top minus bottom. So 2 gives us 4, half of that is 2,
Minus 0.
minus 0 for a grand total of 2. All right, that one will get you to the right answer. Probably not the most efficient way to do it, though. If you think about what this question is,
Triangle.
yeah, from 0 to 2 of x is nothing but a 2 by 2 triangle. So 1/2 base times height would still give you 2. We have that option because we've got a linear edge here. The calculus comes in when we got a curve, something that's wiggling there. This one was just to wake you up and see if you were paying attention and wanted to do it the long, difficult way. Yeah, base times height gives us 2 still. So kudos to you for doing that one, however you chose to do it. Number dos. Okay, this one was supposed to be the 5-second thanks for showing up to the test question, okay? Some of you chose to butcher it, and I don't know why. I guess you just don't like points. Points have offended you in some way. We have cosine
Number 2?
60, this is number 2, yeah.
Points have not offended me, so I took full credit.
Yeah. Points and I are good friends. This is fundamental theorem question. What they want to know is f prime. All right, that's straightforward. If I'm going to take the left-hand side of f to get f prime, then I'm going to do the same thing over here, take the derivative of the right-hand side. So I will take the derivative with respect, in this case, to x of all that stuff. Okay, fundamental theorem says all we have to do is swap out the x's for t's, or the t's for x's, and then compensate with any chain rule derivatives if we have to do that. All right, if we stick in x, we get cosine of 6x plus 1. Compensate with the x's derivative, which is just a fancy 1, and then that constant down there is going to give us a 0 in the end. So this really was a 5-second swap out x's for t's and then move on with life. That's all it was. If you spent more than 5 seconds, or
I stopped for a second, I was like, wait.
can it be that easy?
You
Yes,
know?
it can.
And then I was like, well, either way, it can't be either.
Now, foreshadowing, okay, sneak peek after the commercial break. If you thought that one was super easy, then you just wait till we get to the first free response, and all of you that butchered the first free response, remember how easy this one
I'm
was.
upset I forgot one.
Okay? Yeah, on that third part, or the part B, yeah. All right, number 3. Okay, this is the first one that required you to sort of take stock and think. It wasn't a hard problem, just think and do some arithmetic. You have the antiderivative from -2 to 2 of x to the 7th plus k dx. And when you do that, you were supposed to get 16, find k. Two choices here. One of them is less appealing because this is not a calculator question. With the answer choices they gave me, I could have just plugged them in for k and then done the antiderivatives to see which one gave me an area of 16. With a guess and check like that, I mean, if you got a calculator, easy. Punch it in, change one number, finished. But by hand, a little irritating, kinda. You end up actually doing all the same work like 4 or 5 times. Here's what I would suggest. If you are a guesser and checker, don't start with the first letter. Don't start with A. You'll notice that the answer choices are in order, -12, -4, 0, 4, 12. What would have been the smartest guess to start with?
B.
C.
Oh, yes.
Okay?
I was like C or D.
Now, here's why C is the smart one. If C works, we win. If C gives us an answer that is too small, we go one way, and if it gives us an answer that's too big, we go the other way, and then we really only have to check one other answer. Let's say C doesn't work, so we move up to D and E, all right? So I try D. If D works, I win. If D doesn't work,
Well, then C.
then E wins, okay? So you really only have to check 2 things if you're smart about your guessing. I didn't guess on this one.
I just, yeah.
Just do the arithmetic, okay? So, if we take an antiderivative, relatively easy antiderivative, 1/8 x to the 8th plus kx, okay? We're gonna evaluate that from -2 to 2, and when we do, we should get 16. So let's plug in 2, plug in -2, do the arithmetic, yada, yada, yada. Okay, backtracking to algebra 1, algebra 2, again, algebra 1. If you plug in 2, you got 2 options. You can do 2 to the 8th and then divide it by 8, or you could realize that 8 is 2 to the 3rd,
Yeah.
and then those 3 will cancel, so it's really just 2 to the 5th, which is 32. Stick in 2, we get 2k, and we're gonna subtract. So when you stick in -2, you still get 32. This becomes minus 2k, and all that should equal 16. The 32's cancel. This is positive, so you end up with 4k equals 16, k equals 4. Okay, so that's the I'm not guessing approach to this, the I know what I'm doing approach. Number 4,
Fun, easy points.
which I thought was awesome. We did notice one typo. I don't think any of you really caught it, but there is one typo on this one. Do you see it now?
The I to the 1.
Yeah,
I
well,
called that, but
it
I just
even-
figured.
if I put an I here, I need to have an I where the K is, or I need to put a K equals 1 down where that is, so.
I saw it, but I just figured that's probably the best.
It was just a typo, yeah. I'm gonna go with K equals 1 here, or change the other one to an I. Y'all are used to seeing K.
Either I do that or the answer's not solvable, so.
Yeah, so,
There's not a no answer button.
I'm gonna blame the AP because I pulled this one off of one of their practice problems, so I'm gonna blame that. Although I probably typed it in wrong when I copied it. Okay, what they want you to do is convert this to an integral.
Okay.
So, here's what I know. This is the distance. That's my b minus a. Well, all it tells me it's a distance of 1 to tell me where to start or stop. From that alone, I can rule out e, because e has a distance of 2. Then I look here. Why am I looking in front of the,
Because that's where your A's supposed to be.
that's what my a, like 2 plus something, that gives me a starting point. A in this case is just a ninja 0. Good. So I'm going to start at 0, and I'm going to go 1 unit away, which unfortunately doesn't really help me. By the way, if I ruled out E, then that kind of made it 0 to 1 because all the other choices were that. And then for the last little bit of it, I'm going to look here. This b minus a over n times k is usually what gets stuck in for x. Okay, so all this crap gets turned into an x. My answer was x squared. Not a lot of math. There's no math involved in that one per se. It was more thinking and recognizing. I honestly thought this one was, again, super nice and easy if you're really paying attention. Number 5. Do I have room for number Okay. 5 is the one that where you need to just step back and go, all right, I can do this, I just need to not mess up my arithmetic, okay? So we have the antiderivative from 0 to 1 of dx over root of 4 minus x squared. By the way, if you took decent notes, we did this very same problem as a practice problem the day before. We just used a 9 instead of a 4, but it's the exact same problem, okay? The first thing I would do is rewrite this as, okay, you gotta identify what it is first. It's not on our list of easy ones, but it's really close. It's very arc sine-ish, okay? So my thing here is to turn this into arc sine. Big problem with that is that this needs to be a 1. Now, by turning that into a 1, we're gonna screw up this, but one problem at a time. Okay, so dx over, I'll pull out a 4, leaving me with 1 minus x squared over 4. Is that too tiny? Okay, which will in turn become, oopsie. The root of 4 is 2, so I'm going to pull out a 1/2 in front here, leaving me with dx over square root of 1 minus x over 2 squared. Okay, and I need to write, excuse me, this like this so that I can identify my u. My u in this case is going to be x over 2 or 1/2 x. That makes du 1/2 dx. And I really don't need to doctor at all because I have the 1/2 and I have the dx. This one is about as easy as it gets. So this turns in the antiderivative of du over square root of 1 minus u squared. Now, you have the option to wait until you turn it back into x's and use 0 and 1, or you can convert 0 and 1 to u values. I tend to like to do that just so I never make the mistake of flipping back. If x is 0, then so is u. If x is 1, then u is 1/2. So, and that gives me, that is straight up arc sine. So arc sine of u from 0 to 1/2. All right, here we go. What is the, oh, you're right. Arc sine of 1/2 minus arc sine of 0. Okay. Arc sine of 1/2 is pi6, for those that have forgotten their inverse trig. What angle has a sine of 1/2? That is pi6. And I have to say right now, in the 4th block, the Algebra 3 kids, we're learning about trig, and they don't know what a radian is yet, so if I make the ridiculous mistake of mentioning something in degrees, just laugh at me, please. And point it out and say, you need to fix that. What is the arc sine of 0? 0, yeah. So pi6 minus 0 is pi6. We'll miss you.
I was trying not to interrupt.
Oh.
The sine's 0. Sine 0.
Correct, yeah. Like I said, this one wasn't difficult, it just took a little bit of algebra, and you do enough of these, you'll start to see the shortcut. There is a formula for this one, if you really care about it. I think it doesn't show up enough to waste the brain power to memorize that, unless you really want to. Then we get to free response. You know, I give a question like this every year, and every year I have maybe 1 or 2 kids that truly get it. Part B is the one that everybody really should have gotten without any kind of trick to it. Part A was a tiny bit irritating, tiny.
Really?
It's just, I guess
The
it's
first
just
part.
made it harder than it was.
Yeah,
The second
most
part
people
is-
do. Most people are so used to seeing really hard free responses, they look at this one and go, all right,
I looked
let's
at,
do it.
I looked at first part, I was going, heck yeah.
The second
I was like,
part
this
of
has gotta
A
be
was
it, because
actually
there's no
the
other
hard
way.
part, which I'm
And so I
like,
just finally wrote it down and came my senses back.
then I'm like, wait a second, I don't understand this at all. Part B, part
like,
2 of A.
yeah. So we have, this is what's given to you.
Really? Literally, I got to part 2 of A and I was like, really, Mr. Ford?
What's C?
I was
If
like,
I see.
it's 40.
Yeah, good question. Part A, or 1 of A, says to find f of x. Now, it doesn't seem like it's that bad, but we have to create an f of x that's not here. Here's how we do it. I have an f of t that I need to turn into an f of x. The whole letter swapping out doesn't happen until you do what?
Take a derivative.
Take a derivative. This part right here, the letter swapping out doesn't happen until we take a derivative. So, in order to find f of x, I need to take the derivative
Of the antiderivative.
of the antiderivative. Okay, which is going to be f of x. So, on the right side, it makes perfect sense because taking the derivative then swaps out the variables. But if I'm going to take a derivative of the right, I need to compensate by taking a derivative of the left. So here, I also need to take the derivative of 5x cubed plus 40, which is not 5x cubed plus 40, it is 15x squared. There is f of x.
Who's it was 1?
Most people just rewrote 5x cubed plus 40. Most of the people did that. Most of them did that. All right, second part of this, find C.
So they're just like, oh, it's f of t, the antiderivative. Okay, so
Right,
it is.
The most common wrong answer, of course, is to put 40 or put 0. Some of y'all put 0 just to say it's not there. Here's how we tackle this one. Okay.
Oh, 0 was the right answer. I just got the lucky to get the one.
Yeah, not have worked that way. No. They really don't put the kind of questions where you can do a ridiculously common sense answer, and that's funny to say, but a ridiculous answer like that. All right, here's what I'm gonna do. We know what f of x is,
We do.
which means we also know what f of t is. If this is f of x, then f of t would be 15 t squared. Now, in order to find c, I need to create a c in an equation somewhere, which means I need to do the antiderivative, okay? So, let's see, 5x cubed plus 40, it's pretty hard to write that way. Equals, okay, antiderivative of 15t squared is 5t cubed evaluated from c to x. All right.
Which is kind of good for us.
Yeah, part of it is. Stick in x, you get 5x cubed. Stick in c,
5.
you get 5c cubed. And again, we're subtracting top minus bottom.
Never does.
Notice that the 5x cubes
Cancel.
cancel each other out, so you end up with this statement. 40 equals negative 5c cubed. That's an algebra 2 solving. Okay? Divide by negative 5,
So negative.
and then take a cube root,
Negative 2.
negative 2.
For a second there, I thought it was, I was like square root. I'm like, oh crap,
That's not a pretty one at all. Yeah, but cube root.
But I.
Put I in there, yeah. Find C. It doesn't exist. Gotcha.
How would that work?
They wouldn't give you one like that.
But could that actually exist?
There is a branch of calculus of complex numbers, so yes, there is.
You're just like, it doesn't, so you're going from an imaginary number to a number, it's like, how does this work? How do I evaluate this?
Well, that's what complex numbers, the thing that gets a lot of kids, just as an aside, okay, you all know that I is the square root of -1, which is not real. But if you square that,
It's -1.
you get -1. You take two things that are not real, put them together, and you end up with something that is real.
So I times
Like
I.
women.
Is-
Yeah. It takes stuff that's
Is
not
it-
real and creates something out of it.
Well, still one down.
Yeah, I know, right?
Where's Shane?
Shannon is working on a test out there, yeah. You need some backup, you're like, I think she's too drugged up to really help you today anyway, so.
Oh, I just.
Shouldn't request.
Yes. or she has it, she hasn't given it to me yet, but she has it. Okay, enough of that. Part B, 1B. I thought this was a pleasant way to end the non-calculator, like, all right, here are 3 bonus points, just, you know, leave me some cash or something. So you have g of x is equal to the antiderivative x to 3 of square root of 1 plus t to the 16th. And I tried to make this so absurd that you really wouldn't even try. There's no way for you
No.
to do that. Even if you let u be 1 plus t to the 16th, there is no t to the 15th out there to can't, it's nothing. So I tried to make this pleasant but ridiculous enough, okay? You were to find g prime.
17 just make it understandable, ridiculous.
No. Here's the thing, once again, I'm taking a derivative the same way I did over here on this one. So all I have to do is take a derivative which swaps out the variables. The trick on this one, however, was that these were backwards. So the first part that we get is the one that gets wiped out, and the second part, the minus one, stays behind. So your answer was negative square root of 1 minus x to the 16th. That was the only little tricky trick thing to that one, was the fact that they were backwards.
There's
See if you were paying attention.
You wrote 1 plus x, but you said 1 minus x.
Oh, I'm sorry, yeah, 1 plus x is 16.
So what? Your points don't cover our paper.
Yeah. Okay, non-calculator, soak it in. All the beautiful work there. I thought there were some really interesting places to shine. Like on this first one, yes, it's calculus, and y'all are kind of tunnel vision on calculus, but it really wasn't that bad. This one was 5 seconds, this one required a little thought. No work on number 4, just thinking. This is the only one that really should have taken some time. Unless you have that eidetic memory where you can remember what we did the day before. We used a 9 and ended up with the same kind of answer for that. Deceptively easy that y'all made extremely hard. Or, I'm sorry, deceptively easy that you made way too easy in the wrong way, yeah.
Completely too good.
Alright, clearing the slate, then we get to the calculator part, which y'all honestly did way better on.
I did.
Pretty good. Okay, this is a good board. Okay, and I think this calculator part was really intense with the calculator. I don't think there were very many questions that,
Would have been fun without it.
like 8 and 9 were the only 2 that you did not need a calculator, but 8 required you to remember a lot of geometry, and 9, look at your answer. Your answers aren't even in decimal form, so it was kind of set up in that I don't need a calculator form kind of thing. I'm curious on 6, how y'all chose to tackle this one. F of x was given as 2x squared minus x cubed. G of x was given as x squared minus 2x, and then they gave you a bunch of intervals. So we're going from A to B, and then they want to know for which of these particular intervals is the integral, write this, the integral from A to B of f bigger than the integral A to B from G. Here's how I guess that most of you did it.
I just plugged everything.
You had 3 choices, and you just hit math 9 on each of those and saw which numbers were bigger than the others, okay? If you do it that way, then 2, the A equals 0 and B equals 2 is the only way to do it. This is actually a pretty good lead-in for today's lesson, where you're looking at which area is on top, kind of
I put
thing.
the wrong number.
Did you get that one wrong?
No, I crossed it out, circled that one, so that's the one, and then just put 1.
And then, but, yeah. Unfortunately, on the AP,
Multiple guess.
yeah, on the AP, they could not care less. See, free response, you'd have probably got most of the points for that. And then,
Because I did all the math, I just put the stupid wrong answer.
so, with the calculator, which is a relatively good way to do this one. By the way, you can do it by hand, but these are nice polynomials, it'll just take you a long time to crunch through the numbers.
I voted them being small eyes for the answer, big eyes for the answer and small eyes for
But you
choices.
know what, honestly, if I were doing this without a calculator, I would not actually calculate area. Do y'all agree that the function that is higher would have more area?
Yeah.
So all I would have done is in between these zones, just pick a test point and see which of those functions is actually higher than the other one. And
You
then,
really just take you can just take an antiderivative.
you could, you could do it once and then plug in a whole
And
bunch
then-
of numbers over and over again.
Or then just see which one.
Or here's what I would have done, if the first zone is from -1 to 0, I would have picked like -1/2 and plug -1/2 into this and see which number is bigger. And whichever one is bigger means that function was higher, which means he has more area. That's kind of what we're gonna do today, kind of. So from the calculator, we're gonna get that it's A is equal to 0 and B is equal to 2. That's the only zone where F happens to be bigger than, here's another way to think about it too. That's a parabola that goes up, there's a cubic that goes down. And unless you find the intersection points, again, what we're gonna do today, I think it was just easier to plug them in your calculator. Do you know how to instead of typing the same,
Just go up.
do you know how to do second enter? And it brings up,
Oh, I just go back, I just press up and then press enter.
okay. With your newfangled calculators now, I think I have it set up where you can scroll through all the previous stuff that you've typed in, right? And then just change the number and go from there. All right, for number 7, excuse me. The rate, this is classic, by the way.
Ooh,
This is super
rates.
easy.
I love rates.
The rate, by the way, I paused too. When I saw the word rate, how should you be thinking of the word when you see the word rate?
Delay rates.
Not, well, yeah,
Derivative?
but it's a derivative. It's a derivative of something. The rate at which ice is melting in a pond is given by dV dt is equal to the square root of 1 plus 2 to the t, where V is the volume and T is time. What amount of ice in cubic feet, by the way, they've gone ahead and taken care of the units for you, so you don't need to worry about that, has melted in the first 5 minutes. Okay, they're asking you an actual amount question, which means we need to get from our derivative to the actual amount by taking an antiderivative. So I'm going to take an antiderivative. By the way, this dV dt is misleading. This is not related rates because the actual variable is a t. This is not a related rates problem. So we're going to do the antiderivative of the square root of 1 plus 2 to the t dt.
Are we gonna start doing related rates with antiderivatives and derivatives? Like you gonna give
Related rates is almost exclusively a derivative.
You could do related rates like that, except your variable is.
We'd be working backwards, but the problem is, in related rates, we usually start with the formula and then take his derivative. If I'm working backwards to get the formula, that kind of defeats the purpose because I already knew the formula
Yeah.
to do that. All right, first 5 minutes. What window is that? First 5 minutes, 0 to 5, very good, 0 to 5. And I tried to pick one that was screaming calculator. We don't know how to do this. The one, if we let u be 1 plus 2 to the t, that, we don't have that anywhere to play with, okay? So type it straight into your calculator, and that gives us 14.53. Notice that all of your answer choices were so close together. They're all within 100th of each other, like 200ths of each other.
Mhm.
So guessing on this one, they were really looking for accuracy, okay? 14.53-ish.
But if you put it in the calculator and you got something, you're like, this has to be the right answer because.
It has to be, and it has to be accurate enough on all of them to be able to round precisely to 2 decimal places. Number 8 is the one that I thought would trip some people up if you used a calculator. Here's why.
Because it doesn't look like a circle.
Right,
Yeah.
yeah.
I see that now, I'm like,
Yeah.
wait a second, it was 4 by 4 by 4, it was 4 in each direction, I just wasn't looking at it because it looks like huge and then really small.
Right. This one with a calculator
goodness.
did you wrong, okay?
That was
When you graph that one on your calculator,
It looks like an ellipse all the way.
it looks like a ellipse. Now, I'll be impressed if, not impressed, because you should know this, I'll be impressed why the calculator made it look like an ellipse.
Because it's Windows, not a square.
So if you hit zoom square, your calculator would have done fine. But y'all hit zoom 6, or standard, and it gave you the distortion. Remember on the calculator,
Why can't the screen on the calculator be a square?
I honestly, I don't know why. I would default it to a zoom square if I could do that. But the default button is standard, 10 by 10. The thing is, the screen is rectangular,
Which makes it so that,
and it measures, typically it measures 10 by 10.
which means it doesn't.
Which means this side is distorted to look longer. So on your calculators, your pictures actually look like ellipses. Okay, it came out looking like that, so you're like, oh, it's an ellipse. But in reality, if you set it to zoom square,
It's like, oh, I'm square now.
this is negative 10 to 10, and this actually turns out being somewhere close to 15, I think. It would look like the perfect circle that you're trying to get. Now, if you're a geometry person, you would have remembered that x squared plus y squared equals r squared is the equation of a circle, and then all they did was solve this for y. So it's the top half of a circle.
I thought it was like, I knew that was the equation for a circle, but I
I was
thought
about to say,
the
if
only
I
difference between it and an ellipse was like the number.
If I would have remembered.
You need a number
the
from like a
equation,
2x squared plus y squared,
That's
that's an ellipse.
Which is why I thought the 16 was like, oh, the 16's there. It's
16
making
with
it-
your r, yeah.
Yeah.
Which is why the 4s make sense, because it's a square root of that, so 4 on each side. No. So that was just a kind of a wake-up call, a splash in the face that your calculator will try and lie to you.
It
You
tries.
gotta ask it the right question. Okay, so again, this is standard, which I really don't like. Standard.
I did a discrepancy.
You have a calculator?
It's like
Okay. Go to zoom, you know where the zoom button is? And zoom square, which is
Oh, it's just
5 or 7, or one of those options, zoom square, and it sets it to this.
I remember that film.
And the thing I hate, when you clear your memory, 2 plus 712, it always goes back to standard. I think this should
It'd
be,
a square.
it should be that, but they don't do that.
You should do that. Do like a poster. Don't be standard, be a
Be
square.
square, yeah, it's hip to be square.
It's hip.
Throw back to the 50s, remember those times. Number 9.
Do you remember those times?
I remember reading about them. Up here, I can barely remember the 50s. I was
That's
born in 46. Number 9. The area of the region bounded by the lines x equals 1, y equals 0, and the curve y equals x e to the x squared is. Okay. So we have x equals 1, y equals 0, and y equals x e to the x squared. By the way, I've been in the game long enough. When I see this, I think to myself, what a wonderful use of.